I spent the better part of my Saturday just trying to set up a development environment for a new side project.
Oh no, let me guess. Dependency hell.
Exactly. I didn't write a single line of actual feature code. I was just fighting Webpack configs and, trying to get the local server to spin up.
I mean, it really feels like you're a plumber trying to build a house, right?
Yes, I spent all day just organizing the toolbox.
And that right there is the exact friction point we're seeing in software right now. You have this amazing architectural vision, but you get bogged down in the plumbing.
Which is exactly why this new deep dive we're doing into the February 2026 OpenAI report is really sticking with me.
It's a fascinating report.
They claim to have built a massive product over 1 million lines of code. And get this, a human didn't manually type any of the application logic.
0 lines.
Right. They're calling it harness engineering. But part of me wonders, is that just a fancy rebranding for prompt engineering?
It is actually significantly more structured than just prompting. Think of it as moving from being the bricklayer to being the site foreman.
Okay, I like that analogy.
The humans didn't write the code, but they architected the environment, the harness, that allowed the AI agents to write it safely.
Right, but usually when you add more hands on deck, even digital ones, you hit Brooks' law.
Adding manpower to a late software project just makes it later.
Exactly, because communication overhead just explodes. Did they see that happen here?
Surprisingly, no. They actually inverted Brooks' law. Their throughput increased as the team grew. They averaged about 3.5 pull requests per engineer per day.
That's huge.
It is, because the humans weren't typing, they were reviewing. The harness essentially acts as this massive automated integration test suite that constrains the agents. Humans steer and the agents execute.
So humans define the intent, and the tests and the agents handle the actual how. But here's where I get a bit skeptical. Agents are notoriously bad at seeing what they're actually doing. If an agent breaks the UI, how does it know? It doesn't have eyes.
And that is the breakthrough they call agent legibility. They realize that building for agents means giving them completely different senses.
So what do they do instead of computer vision?
They didn't just ask the agent to look at a screenshot, they wired the agent directly into the Chrome DevTools protocol.
Oh, wow. So instead of guessing what a button is visually, the agent has direct access to the DOM and the network traffic.
Exactly. It allows the agent to validate its own fixes with absolute certainty. And they did the exact same thing with logs.
How so?
Instead of using human-readable text logs, they configured the system to emit structured data, so the agent could query it using tools like LogQL.
So the agent is basically querying a database of its own performance to see if it met the success criteria.
Right. Optimizing the workspace for the worker.
That's incredibly clever. But what about the code quality? We've all seen AI generate absolute spaghetti code.
Oh,
If you have bots generating 1 million lines of that, isn't it just a maintenance nightmare waiting to happen?
That's where the concept of mechanical taste comes in. They treated their documentation completely differently, not as a 1,000-page manual to be read, but as a structured map for retrieval.
Meaning the agents can just pull the rules they need when they need them.
Yes, and they enforced human taste using custom linters. If an agent tries to import a library that isn't allowed, the error message doesn't just flag it. It actually teaches the agent about the architectural boundaries.
The compiler basically lectures the agent on project architecture.
Exactly. And they even went a step further with garbage collection.
Wait, garbage collection usually refers to memory management, right? Not source code.
In this context, they had background agents running continuously, just dedicated to refactoring. If a piece of code drifted or got sloppy, these background agents would rewrite it.
Paying down technical debt automatically.
Continuously, while the main agents just focused on new features.
That is the ultimate dream, a code base that literally heals itself. But setting up that kind of harness sounds incredibly complex. You need serious expertise to build that scaffolding up front.
It is a heavy lift at the start, and actually that is where a partner like Embersilk comes in.
Yes, this show is proudly sponsored by Embersilk.
So if you are listening to this and realizing you need to shift your own business from manual coding to this kind of agent-driven architecture, Embersilk specializes in exactly that.
They help you find those integration points for AI training, automation, and software development.
Uncovering exactly where agents can make the biggest impact for your business.
Or even your personal life. Check out embersilk.com for all your AI needs. Because really, this entire shift we're talking about today isn't just about speed, it's about leverage.
It really is. The highly optimistic take here is that we are finally removing the boring work. We're automating the boilerplate and the syntax errors so humans can just focus on high-level design.
The golden principle.
Exactly. It creates a world where the barrier to entry isn't your ability to type correct syntax. It's simply your ability to articulate a clear problem.
And that leads to a pretty provocative question for everyone listening. If the barrier of writing code is completely removed, what complex problem would you finally solve?
The possibilities are literally endless.
I'd probably finally fix that chaotic photo organization script I've been putting off, or maybe tackle something much bigger. We'll leave you to mull that over. If you enjoyed this deep dive, please subscribe to the show and leave us a 5-star review. It really helps get the word out.
Thanks for tuning in.